Hey, Algebra 1. Today we're talking Lesson 7, Measuring Variability for Skewed Distribution. What is the interquartile range, which is the IQR. First of all, let's talk about this dot plot. Consider the following scenario. A television game show, Fact or Fiction, was canceled after 9 shows. Many people watched the 9 shows and were rather upset when it was taken off the air. A random sample of 80 viewers of the show was selected. Viewers in the sample responded to several questions. The dot plot below shows the distribution of ages of these 80 viewers. Let's talk about this before we answer that first question. So what does the dot farthest to the left of this dot plot tell us? All the way down there. It tells me that there was a 5-year-old watching, right? Would you consider this distribution symmetrical? Not really. I would sort of guesstimate it like that. So I've got more viewers or a cluster at the older ages. What age would you describe a typical age for this sample of viewers? Goodness. There's a whole bunch right there and a whole bunch right there. I'm going to guesstimate typical age for a sample of viewers, maybe about right there. A reviewer of the show indicated that it was a cross-generational show. What do you think that term means? Oops. Cross-generational. That means that it's set to reach a wide array of ages. Cross-generational means that you've got like baby age, parent age, and grandparent age, and the TV show is trying to reach all of those generations. So the viewers varied in age. People from more than one generation watched the show. Do data in the dot plot confirm or contradict the idea that it was a cross-generational show? Sort of confirms. It definitely did reach from the lowest to the highest of 75. It reached everyone pretty well, but, here's where they ended up, really. But yeah, I would say it confirms the data. You have infants, parents, and grandparents. So what could be the reason for the cancellation of the show? What do you guys think? Think about it. My idea would be cross-generational shows, something that's supposed to reach a 5-year-old and a 75-year-old. It's really hard to get a sponsor for. Sponsors would be people who purchase airtime for commercials because they're trying to target a certain age group. So a sponsor can't buy commercial time to target a 5-year-old and a 75-year-old, right? All right, let's think about the data. A data distribution that's not symmetrical. We've talked about it being skewed. So skewed, we would sort of refer to a data stretch. And a data would stretch either to the left or the right. This data is stretching to the left. It is skewed to the left. The tail is on the left. Yeah, that's it. Let's get into this next question. Approximately where would you locate the mean or the balance point for, where would you locate the mean or the balance point for the distribution? I would not do as close to 70 as that. I would probably go closer to, 45, somewhere between 45 and 60, somewhere in here would be my balance point, right? And you guys may have guessed something different. I don't know. How does the direction of the tail affect the location of the mean age compared to the median age? This is super duper important. This is how we decide which data that we pay better attention to. Do we pay better attention to the mean, or do we pay better attention to the median? I have a tail on the left. This means that my data is skewed to the left. So my data is skewed to the left, so the mean is typically in the direction of the tail. So the mean age would be to the left of the median age. Remember, the median's the middle. If I have a tail, the mean is skewed towards that tail. So my mean is in the direction of the tail, therefore the mean age would be to the left of the median age. Cool? So number 3 says the mean age of the above a sample is about 50. Do you think this age describes the typical viewer of this show? No. We know when the data is skewed, the mean is not good data. It's not a good average. It is an average, but it's not a good representation. I said put date, didn't I? Is not a good, we can say, representation of the data. So the mean was 50. Our estimate was more around, 45 to 60 we said, so 50's in there. It doesn't adequately reflect the older ages, all those 70 and 75-year-olds, doesn't adequately reflect them at all. All right, use the above dot plot, which is below. Construct a box plot over the dot plot by completing the following steps. Locate the middle 40 observations. I've got 80, so I want the middle 40. I need to remove 20 from the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry, I have to start over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I'm right here. Middle 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, oh wait, 20. That was where I needed to stop, sorry. So I took 20 from the top, 20 from the bottom, I found the middle, and drew a box around these values. This is the middle 50%. Calculate the median. The median is the middle, so I need to move 20 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the median is 60. Draw a line that extends from the upper end of the box, so to the largest observation. I'm going to draw it up here, and that's not right. It's a very short line that stops at 75. I'm going to put that down here, though. And then draw a line from the lower edge, and that would stop at 5. The box was started right at 40, and the box was stopped right at 70. Okay, I have 1, 2, 3, 4, 5 very important points. Those 5 values are called the 5-number summary for statistics. I have the minimum age, which was 5 years old, the lower quartile, which, I need to look at that dot plot again, it was 40. You'd think I could remember that. The median age, which was 60. The upper quartile, which was 70, and the maximum age, which was 75. That's my 5-number summary, which is an important thing that you'll have to be able to repeat. And your one variable stats button in your calculator will get that for you. Okay? So what percentage of the data does the box part represent? That's my box. I've got whiskers. The box is 50%. I actually have 25% to the left of the median and 25% to the right of the median. What percentage of data fall between the minimum value, which was 5, and quartile 1, which was 40? That percentage is 25%. And then the quartile 3, which was 70, and the maximum value was 75, that was also 25%. Because 25% plus 25% plus 50% equals 100%. Okay, let's move on to something else. Still with the same data. An advertising agency researched the ages of viewers most interested in various types of television ads. Consider the following summaries. I've got ages 30 to 34, ages 46 to 55, 56 to 72. And all their target products and services are different. So advertising agencies, depending on the age of the viewers, are going to put different ads into their commercials. So the mean age of people surveyed was approximately 50 years old. As a result, the producers of the show decided to obtain advertisers for a typical viewer of 50 years old. According to the table, what products or services do you think the producers will target? Based on the sample, what percentage of the people surveyed about the fact or fiction show would have been interested in these commercials if the advertising table is accurate? So for 50 years old, we're going right there, financial services, appliances, and furniture. So ages 46 to 55, financial services, etc. But if I go back to the dot plot, I could only find 12 viewers in that age range. I've got 80 viewers altogether. That gives me 15% of my viewers are in that range. What a waste of money for those advertisers. They're spending a ton of money to target the mean age of 50 when only 15% of the people are in that age group. So the show failed to generate the interest the advertisers hoped. As a result, they stopped advertising the show and the show was canceled. Kristen made the argument that a better age to describe the typical viewer is the median age, which was 60. What is the median age of the sample? Check. What products or services do the advertising table suggest for viewers in the median age? That would be the retirement planning, etc. Oops, can't spell. So what percent of the people surveyed would be interested in the products and services suggested by the advertising table if the median age were used to describe a typical viewer? So the median age of 60 falls in that 56 to 72-year-old range on the table. If I go back to the dot plot and count how many viewers are between 56 and 72, I found that 31 dots were there. I've got 80 dots altogether. That gives me a percentage of 39%. So that's much better for the advertisers to buy spots for that age group because they're reaching 39% of the audience. which is much better, especially for a generational show. What percent of the viewers have ages between Q1 and Q3? Q1 and Q3. The difference between Q3 and Q1 is called the interquartile range. And it's really Q3 minus Q1. That is 50% of my viewers, because that is in the box. And, oh my goodness. That is in the box, which is 50% of the viewers. What is the IQR data for this distribution? Well, Q3 is 70, Q1 is 40, so that gives me 30 years. The IQR provides a summary of the variability for a skewed data distribution. So there I've got my variability, which is something that's really important in statistics. The IQR is a number that specifies the length of the interval that contains the middle half of the ages of viewers, so that 50%. How big is that interval? So the interval for this was 70 years old to 40 years old, which was 30 years. We're running out of space already. Your IQR, the smaller it is, the less variable your data is. The larger it is, the more variable. I don't know what is wrong with my spelling and handwriting today. The more variable your data is. The larger IQR, it's more variable, so the show is popular across generations, but harder to target your audience. So I've got a wide range of, wide age group, which if you like that, that's great, but targeting advertisers is going to be difficult. Is going to be very difficult. Do you agree with Kristen's argument that the median age provides a better description of the typical viewer? When you have skewed data, your median is a better representation. Okay, exploratory challenge. Now we're going to talk about extreme values. So students at Waldo High School are involved in a special project that involves communicating with people in Kenya. Consider a box plot of the ages of 200 randomly selected people from Kenya. What we're talking about now are these. So a data distribution may contain extreme data, specific data values that are unusually large or unusually small relative to the median and the interquartile range. A box plot can be used to display extreme data values that are identified as outliers. Each star in the box plot represents the ages of 4 people from the sample. Based on the sample, these 4 ages were considered outliers. Estimate the values of the 4 ages represented by a star. I did this on paper a lot better than I can do it on my iPad. So I have about 72-ish, 77, I'm guessing. Your values may be different than mine. And 100 years old would be reasonable estimates. An outlier is defined to be any data value that is more than 1.5 times the IQR away from the nearest quartile. Okay? Important. So what is the median age of the sample of ages from Kenya? Okay, it's right about there. So I'm going back to my piece of paper, which is a lot easier for me to figure things out. That's about 18 years old. Median. Quartile 1, I read, is about 7 years old. Quartile 3 is about 32 years old. So the IQR is 32 minus 7, or 25. Multiply the IQR by 1.5, and I get 37.5 years. We're going to use that in number 18. So add the 37.5 years, add it to Q3, and we had Q3 was 32 years. That equals 69.5 years, or, I don't know, about 70 years. So that anything above 70 is the outlier. So anything greater than 70 is an outlier. Are there any age values that are less than Q1, which Q1 was 7, minus 1.5 times the IQR? Are there any? No. Because there are no negative ages, right? Silly. Oh, that was it. All right, this is actually a good review. Non-symmetrical data distributions are referred to as skewed. We've got left skewed and right skewed. Data spread out longer like a tail on the left. Data spread out longer like a tail on the right. The center of skewed data would be described by the median, not the mean. Variability of a skewed data is described by the IQR. A small IQR is not variable. A big IQR is variable. The IQR describes variability by specifying the length of the interval, middle 50%, and then outliers. 1.5 times the IQR. You either add it to Q3 or subtract it from Q1, and it would tell you if you have any outliers. If it's greater than that, Q3 plus 1.5 IQR, then it's an outlier. If it's less than Q1 minus 1.5 times the IQR, it's an outlier.